In this video, we're going to look at some applications of trigonometry. In other words, there'll just be a little story that goes with the question, and we have to try and figure out what information we've been given so that we know if we should use sine, cos, or tan. But before we look at a couple of examples, we just want to look at the concepts of angles of elevation and depression and what exactly do they mean. First of all, an angle of elevation is the angle measured upwards from a horizontal to a fixed point. In other words, it will be someone on the ground looking up at the top of the tower, and that would create an angle of elevation. So in this case, the angle of elevation is looking up. The angle of depression is the angle measured downwards from a horizontal to a fixed point. In other words, if I have a look at this drawing, it will be the top of the statue looking down to the ground. So from a horizontal plane, we look down towards the ground, and that will create an angle of depression. And what is very important to notice is that the angles of depression and elevation are equal alternate angles. So if you are given an angle of depression, you can use alternate angles to place that angle inside the triangle. Let's look at a few examples. In the first example, a 12-meter ladder rests against the side of a house. The top of the ladder is 9.5 meters from the floor, and we need to calculate the angle that the foot of the ladder makes with the ground. So first, let's get a little picture. So we've got our ladder that is 12 meters long, and it rests against the side of the house, and the top of the ladder is 9.5 meters from the floor. So those are the measurements that we have. So you'll notice we have a little right angle triangle, so we can use our trig functions. We just need to decide which one we're going to use. We've got 9,5 meters, which is opposite my angle, so I have the opposite side, and I've got the 12 meters, which is the hypotenuse. So we need to use the trig function with opposite and hypotenuse. So we will be using sine to calculate this angle. So sine of theta is equal to the opposite side, which is 9,5, over the hypotenuse, which is 12. Now, because we need to calculate the angle, we are going to go shift sine on our calculator. So shift sine of 9,5 over 12, and we end up with theta is equal to 52 degrees if I round off to the nearest whole number. Example 2 is very similar. A man stands at a point P 45 meters from the base of a building that is 20 meters high. Find the angle of elevation of the top of the building from the man. So again, we want to just get a little picture. So we've got a man in the building, and he is 45 meters from the base of the building, and the building is 20 meters high. We want the angle of elevation, in other words, from the horizontal on the floor to the top of the building. We need to calculate that angle, and you can call that angle anything you want. We generally use the Greek letters, so theta is the most common one we use, but it doesn't matter which symbol you have there. So now we just need to decide which information we've been given. We have 20 meters, which is opposite my angle, and we have 45 meters, which is not on the hypotenuse, so it must be the adjacent side. So which trig function works with opposite and adjacent? Well, tan. So this time, tan of the angle that we're looking for is the opposite side over the adjacent side. So to calculate the angle, we are going to go shift tan of 20 over 45. And if we round off to the nearest degree, we get that theta is equal to 24 degrees. Example 3 is slightly more difficult. It actually came out of an old exam. Spider-Man is standing on top of a building CD, and he needs to rescue his damsel in distress, who is stuck on the 5th floor of the building at point A. The 5th floor is 17,5 meters above the ground, and the ground is, so that distance above the ground is AC. From a street lamp across the road at B, the angle of elevation to the top of the building is 63 degrees, and the street lamp is 18 meters from the front door of the building. This is all illustrated in the picture, and we need to just determine the distance AD, in other words, the distance that Spider-Man needs to drop down to rescue his damsel in distress, and this time correct to 1 decimal place. When we look at this drawing, everything has been filled in for us that we need, and the only angle I have is the 63 degrees, which means I need to work with a full triangle. The big triangle that I've illustrated in red. Okay, now I don't need the whole side of the triangle, but if I calculate the whole side, I will be able to subtract 17,5 meters to get the little green portion that's left. So we're going to use that red triangle and decide we want the opposite side. We've got the adjacent side when we look at 63 degrees. So we've got opposite and adjacent. So we should be using tan. So the tan of 63 degrees is going to be the opposite side, which is the whole side, DC, over the adjacent side, which is 18. So if I want to calculate DC, I'm going to multiply 18 on the left-hand side. So I get 18 times tan 63. If I type that into my calculator and round off to 1 decimal place, I get 35,3 meters. But that's the whole distance DC, and I only need the top portion. But I know that the bottom piece is 17,5 meters, so if I subtract that from 35,3, the top piece, the little piece that Spider-Man has to drop down, is equal to 17,8 meters. Let's look at one final example. In this case, a 25-meter tall lighthouse sits on top of a cliff that is 30 meters above sea level. A fishing boat is seen 100 meters from the base of the cliff, vertically below the lighthouse. We need to find the angle of depression from the top of the lighthouse to the boat, to the nearest degree. So let's just look at our triangle. You'll notice I have a distance of 55 meters. That's because the lighthouse is 25 meters and the cliff is 30. So if I add the two together, I get 55 meters, and it's 100. The boat is 100 meters from the base of the cliff. And we need to calculate the angle of depression. But you'll remember from the first slide that the angle of depression is actually equal to the angle of elevation. They are alternate angles. So if I can calculate the angle inside my triangle, it will be exactly the same as the angle of depression. Now let's just see what information we have. We've got 55 meters, which is opposite angle D, and we have 100 meters, which is adjacent to angle D. So opposite and adjacent will make use of the tan function. So the tan of angle D is the opposite side, so 55 over 100. And to calculate D, to calculate the angle, we need to go shift tan of 55 over 100. And to the nearest degree, D is 29 degrees. So just two things here. Just remember that 55 meters came because the lighthouse was 25 meters and the cliff was 30 meters. So to get to the top of the lighthouse, I add the 2 and I've got 55. And if ever we need to calculate the angle, we will always go shift tan or shift sine or shift cos, whichever trig function we are working with. And the final thing that we need to remember is an angle of elevation and an angle of depression are in fact alternate angles, so they will always be equal to each other. Thanks for watching Max Maths. If you liked what you saw, please like, share and subscribe.